final operation that we're going to tackle in the complex number system is division. And in order to divide, we're going to end up multiplying by its complex conjugate. So we're going to use complex conjugates to help us divide. So really in complex numbers, there really is no such thing as division because we're always going to change it into multiplication of the complex conjugate. So in essence, all division is going to be turned into multiplication. So here's what they're saying. Complex conjugates. Two complex numbers in the form of a plus bi and a minus b are called complex conjugates, which we just looked at in the previous example that I pointed out. Complex conjugates can be used to rationalize an imaginary denominator. Now the word rationalize means you must have a rational number in the denominator. So if you think about your number systems, a rational number has to be a ratio, rational, must be a ratio of two integers. But you have to rationalize the denominator, which means rationalize the denominator means it has to be a rational number in the denominator. So when you look at these, your denominator must be rational. If a denominator is irrational, the only way the denominator is irrational is if you have the square root of a number, such as 2. Square root of 2 can't stay in the denominator. We talked about this extensively last year. You can't leave the square root of 3 in the denominator. No radical can be left in the denominator. So in our case, we're going to be looking at values that are going to have in the denominator an I. So if it's 2 plus I is 2 plus the square root of a negative 1. So in essence, we have a radical in the denominator. So the rule is to not leave radicals in the denominator. If you have a radical in the denominator, it is not simplified, or in this terminology, you have not rationalized the denominator. So keep that in mind what we're trying to do. We're going to multiply the numerator and denominator by a complex conjugate of the denominator. So the first thing we're going to do is we're going to rewrite these. There's not a lot of benefit of seeing them as a division problem, so it's going to be 5 minus 3i. Division is another way of writing a fraction bar, 1 minus 2i. So what we want to do is we want to get rid of this I out of the denominator because that's like the square root of a negative 1. You cannot leave those there. So what they tell you to do is multiply the top and the bottom by the complex conjugate. Now the complex conjugate of the denominator is 1 plus 2i. They're going to be exactly the same. The only difference is going to be positive and a negative sign. So we want to make sure that happens. Whatever you do at the top, you do to the bottom. So this number sitting right here is an equivalency of 1. We're multiplying by 1, which means we'll change its appearance but without changing its value. So this is going to equal. And now since we learned how to multiply, we'll apply our double distributive property here, FOIL. So 5 times 1 is 5. 5 times 2i is 10i. And negative 3i times 1 is negative 3i. And a negative 3 times 2i is a negative 6i squared. On the bottom, I know that they're complex conjugates, and I know that the outside and inside of complex conjugates always cancel, so I just need the first and the last. 1 times 1 is 1. Then minus 2i times 2i is minus 4i squared. Now what we have left to do is some simplifying with some of our I squares and collecting like terms. So it's going to be 5 plus, then we got 7i, and then we're going to have a negative 6i squared, and I squared is a negative 1, so it's a negative 6 times negative 1 plus 6 all over. This is 1, then it's, again, we've got this negative 1 sitting here, and negative 1 times a negative 4, which is plus 4. So when we get finished, we have 5 plus a 6, which is 11, plus 7i over 5. We're almost home. We have to make sure that this gets put in standard form. This is not in standard form. Standard form is a plus bi. There's no fraction bars in between those. So what we're going to do is we're going to break up our fraction. This is the same thing as 11 fifths, there's a real number, plus 7 fifths, real number, I. Finished. So in order to divide, you multiply by its complex conjugate. And so we'll take a look at another example here. First thing we're going to do is we're going to write as 3 plus 4i divided by 1 plus 5i. In order to divide, you multiply by its complex conjugate. So we multiply top and bottom by the same thing. It's going to be 1 minus 5i, 1 minus 5i. This is an equivalency of 1, which means we're changing the appearance but not changing the value, and we're going to rationalize that denominator and get rid of the radical off the bottom. So we'll perform our multiplication. 3 times 1 is 3. That's a negative 15i. That's a positive 4i. And this is a negative 20i squared. In the denominator, remember the outside and inside cancel, so just the first and the last. It's 1 times 1 is 1. That's going to be minus 25i squared. Okay, and after you do enough of these, you're going to recognize that I squared is always a negative 1, and that I squared there is always a negative 1, so it's going to end up changing that sign. So we're going to have on the top, I'm going to write it up above, 3, and it's going to be a negative 11i, and then this is going to end up being a negative 1 times a negative 20, or plus 20, and this is going to be a 1, then a negative 25 times a negative 1 is plus 25. So we're going to collect our like terms on the top. We're going to have 23 minus 11i all over 26. Make sure you put it in complete standard form, so it's going to be 23 over 26 minus 11i 26. And I actually don't want to write the I up there inside that fraction. I want it off to the side. 11 26i. Okay, now let's take a look at a little more difficult problem, or at least a little extension on what we're doing. It's 1 plus 3 square root of 3i all over 1 minus the square root of 2i. We're still dividing. We still have a radical in the denominator. We got a square root of 2 and an I. So we're going to multiply by its complex conjugate, which would be 1 plus the square root of 2i. 1 plus the square root of 2i. Use our FOIL or double distributive property. We got 1, and then we've got plus the square root of 2i. Then we have our innermost plus the square root of 3i. And our last, we got the square root of 3 times the square root of 2, which is the square root of 6, and I times I is I squared, over our conjugate, which will be the first and the last, 1 minus the square root of 4i squared. Okay, so we've got some simplifying that we can do here on the top. What I'm going to do is write as 1 plus, that's not a very good color, let me try a different color. 1 plus the square root of 2i plus the square root of 3i. There's no way to combine those because you can't add a square root of 2 and a square root of 3, but you'll see we're going to do it a bit later. I squared is a negative 1, so that's going to be minus the square root of 6. On the bottom, the square root of 4 is 2, so it's 1 minus 2 times a negative 1, or it's going to be a negative 2 times negative 1 is a positive 2, or 1 plus 2, which is a 3. Okay, so I'm going to come off the side here and hopefully I can get some of this squared away. Remember, we must get it in the form of a plus bi. So I need the real parts up front. My real parts are 1 and a negative square root of 6. So I'm going to put up a 1 minus the square root of 6. Then my imaginary parts are the square root of 2i and the square root of 3i. Well, we're going to write that as the square root of 2 plus the square root of 3, parentheses, I. And that's going to be plus, because there's a positive square root of 2. And here's our real part, 1 minus the square root of 6. So here's our a, here's our b, but we still have to divide each of those by 3. So divided by 3, divided by 3. So 1 minus the square root of 6 all over 3, plus the square root of 2 plus the square root of 3 all over 3i. Okay, so it can get a little bit more complex, but your procedure is still the same. Multiply by your conjugate.